Welcome to my sleep science channel. Tonight we begin a long and peaceful journey into one of the strangest questions humanity has ever asked. Why is the universe so quiet? Before we begin, take a moment to like the video, subscribe to the channel, and tell me where you are watching from tonight. Somewhere on Earth, under a quiet ceiling, beside a window, or beneath the soft glow of a lamp, you are listening to a story that stretches across billions of years and unimaginable distances. Tonight, we begin close to home, on the ancient Earth beneath the oldest skies humanity has ever seen. Long before cities, before electric lights, before engines and airplanes, and glowing screens, the nights on Earth were almost completely silent. Thousands of years ago, when the first humans rested beside rivers or slept near small fires, the night sky looked far larger than it does today. Without light pollution, the stars filled the darkness from horizon to horizon. The Milky Way stretched across the sky like pale smoke, so bright that ancient people could walk by its light alone. Every night above them was a universe overflowing with stars, and yet, despite the endless lights above, there was only silence. The people of ancient Earth did not know what stars truly were. They did not know about galaxies, planets, or the enormous scale of the cosmos. But they understood something emotionally powerful about the night sky. It felt distant, calm, untouchable. Even the brightest stars seemed quiet, as though the universe itself were watching silently from far away. If you stood outside on Earth 10,000 years ago, you would hear the wind moving through trees, insects calling in the grass, waves striking the shore, and the crackle of firewood burning nearby. But above all those earthly sounds, the stars remained completely still. No whisper came from the moon. No roar echoed from distant planets. The sky moved slowly through the seasons in complete silence. This silence is partly an illusion created by distance, but it is also something deeply real. Sound requires matter to travel through. On Earth, sound moves through air as vibrations. A voice shakes the air molecules around it, and those vibrations move outward until they reach another ear. Thunder travels through the atmosphere. Ocean waves crash through dense air near the shore. Music fills a room because invisible vibrations pass through the air between walls. Space is different. The space between planets and stars is almost entirely empty. There are a few lonely atoms drifting through the darkness, but not enough to carry sound the way air does on Earth. Even if a giant star exploded nearby, a human floating safely in empty space would not hear it. The explosion would shine with unimaginable brightness, and radiation would flood outward across the void. But there would be no sound. The universe is not truly silent because nothing happens there. It is silent because the cosmos is mostly empty. This idea can feel strange because many movies and stories imagine space as loud. Giant battles roar between spaceships. Explosions thunder through the darkness. Engines scream across galaxies. But the real universe is quieter than almost anything humans have ever experienced. Astronauts aboard spacecraft can only hear sounds through direct contact, through vibrations inside the ship, through radios, or through their own breathing inside their helmets. Outside the spacecraft, there is only stillness. Even our nearest celestial neighbor, the moon, exists in this silence. When astronauts walked across its dusty surface during the 20th century, they moved beneath a black sky untouched by atmosphere. No wind moved there. No weather existed. No birds, rivers, or forests softened the emptiness. The astronauts could speak to one another only through radio systems built into their suits, their boots pressed into ancient dust that had rested undisturbed for millions of years. Every movement happened in near-perfect silence. For ancient humans, the stars became symbols of mystery, partly because of this quietness. Thunderstorm felt alive and immediate. Oceans crashed loudly against cliffs. Volcanoes exploded with terrifying force, but the stars watched silently from above generation after generation. Entire civilizations rose and disappeared beneath those same distant lights. The silence of the universe also changes the way humans think about themselves. During the day, Earth feels enormous. Cities stretch across landscapes. Mountains rise over forests. Oceans cover most of the planet. Human history feels vast and important. But at night, beneath the stars, people often feel small. The quiet sky reminds us how tiny our world really is compared to the endless darkness beyond it. Yet there is something comforting about that silence too. The universe is not rushing. Galaxies move slowly across billions of years. Stars live for unimaginable lengths of time. Even light itself can spend millions of years traveling quietly through darkness before reaching a human eye. The cosmos unfolds with incredible patience. Tonight, as you rest beneath your own ceiling and listen to these words, the universe above you remains silent. Stars continue burning far away in the darkness. Planets drift through cold, empty space. Invisible clouds of dust float between distant suns. Entire galaxies slowly rotate in the blackness beyond human sight. And through all of it, the universe remains calm, vast, and almost perfectly quiet. Long before telescopes existed, before maps of the stars, before science could explain planets or galaxies, human beings were already staring upward into the darkness with wonder. The earliest people on Earth lived in a world where night felt enormous. There were no glowing cities brightening the horizon, no highways, no aircraft lights moving overhead. When darkness arrived, it truly arrived. The stars became the brightest and most mysterious part of the human world. Imagine standing beside a small fire tens of thousands of years ago. The earth around you is dark, except for moonlight and flickering flames. The air is cool. Somewhere in the distance, an animal calls across the open land. Above you, thousands upon thousands of stars stretch endlessly across the sky. The Milky Way appears so bright and wide that it almost seems like a pale river flowing overhead. To ancient eyes, the universe did not feel empty. It felt alive with mystery. The first humans did not know that the stars were enormous suns burning billions of kilometers away. They did not know that Earth itself was moving through space. Many ancient cultures believed the sky was a giant dome surrounding the world. Others imagined the stars as fires lit by gods, or tiny openings into another realm beyond the heavens. Nearly every civilization created stories to explain the lights above them, because humans naturally search for meaning in silence. One of the most powerful things about the night sky was its consistency. Seasons changed, rivers flooded, storms destroyed forests, and animals migrated across the land. But the stars returned in familiar patterns year after year. Ancient people learned that certain stars appeared before winter, while others rose during warmer seasons. Over time, humans began using the sky as a clock, a calendar, and a guide. The stars quietly shaped human civilization. Farmers planted crops according to the movements of constellations. Sailors crossed vast oceans using the position of the stars above them. Travelers walked through deserts at night, guided only by the heavens. Even though the universe remained silent, it became one of humanity's oldest companions. Some ancient monuments were carefully aligned with celestial events. Massive stone structures built thousands of years ago still point towards sunrise during solstices or toward important stars in the night sky. These structures remind us that early humans spent enormous amounts of time watching the heavens. The quiet universe captured their imagination completely. For ancient people, darkness itself was different from modern darkness. Today, many humans rarely experience a truly dark night. Street lights brighten cities. Screens glow indoors. Cars move constantly through the night. But ancient humans knew deep darkness intimately. When the moon disappeared from the sky, The world became almost completely black except for the stars above. In such darkness, the sky felt larger than the earth beneath it. The stars seemed endless, and because the universe gave no obvious answers, humans filled the silence with myths and legends. Some imagined heroes placed among the constellations. Others believed the stars were ancestors watching from above. In many cultures, the sky became connected to ideas of eternity, memory, and the unknown. The silence of the cosmos may have influenced human thought more deeply than we realize. When people stare into something vast and quiet, their minds naturally begin asking difficult questions. What are we? How far does the universe go? Are we alone? Why is there something instead of nothing? These questions emerged long before modern science. The silent sky invited them. Even children in ancient times likely experienced this feeling. Imagine a child lying beside a fire while older members of a tribe point toward the stars and tell stories about them. The child listens quietly while staring upward into the darkness, feeling both safe and small at the same time. Across thousands of generations, this moment repeated endlessly throughout human history. The moon also played a powerful role in the emotional experience of the night sky. Unlike the distant stars, the moon changed visibly from night to night. It grew larger, then faded away, then returned again. Ancient people watched eclipses with fear and fascination. Some believed celestial beings were swallowing the moon. Others thought the heavens themselves were changing. Yet despite these dramatic sights, the universe itself remained silent. A meteor could blaze across the atmosphere in brilliant light, but the stars beyond it remained calm. Planets wandered slowly across the sky without sound. Even comets, which frightened ancient civilizations because of their strange glowing tails, moved silently through the heavens. This silence gave the universe a dreamlike quality. The sky seemed detached from ordinary life on Earth. Mountains eroded, rivers shifted, forests burned and regrew. Human lives began and ended quickly. But above everything, the stars continued their slow, silent motion across the ages. As centuries passed, humans slowly learned more about the cosmos. Philosophers began wondering whether stars might be distant worlds. Early astronomers carefully tracked planetary motion. People noticed that some lights wandered differently than others. The word planet itself comes from an ancient term meaning wanderer, because planets drifted slowly through the fixed background of stars. Still, even as knowledge grew, the silence remained. Humanity could observe the heavens, but not hear them. The universe revealed itself through light alone. Every star became a distant signal, traveling quietly through darkness across unimaginable stretches of space. Tonight, modern humans still experience something similar to what ancient people felt long ago. Even in a noisy city, there are moments when someone looks upward and suddenly feels the calm silence of the cosmos. Beneath all human activity, beneath every busy road and glowing building, Earth is still drifting quietly through the universe, exactly as it did thousands of years ago. And above us, the stars continue watching in silence, just as they always have. One of the strangest things about the universe is that it looks violent and energetic, yet remains almost completely silent. Stars explode, galaxies collide, giant planets spin through darkness at incredible speeds. Black holes consume matter with enormous force. But if a human could somehow float safely in the emptiness between worlds, there would be no sound at all. The universe would appear active and alive. Yet it would feel quieter than the deepest night on Earth. On our planet, silence is actually very rare. Even in peaceful places, there are always tiny sounds hiding in the background. Wind brushes across trees. Water moves quietly underground. Buildings creak softly as temperatures change. Insects hum null. Distant traffic echoes through the air. Human ears evolved in an environment filled with atmosphere, weather, animals, and movement. Earth is naturally noisy because air surrounds everything. Sound itself is simply vibration moving through matter. When someone speaks, their vocal cords vibrate and disturb the air nearby. Those vibrations travel outward in waves until they reach another person's ears. Thunder travels through air after lightning heats the atmosphere. Music moves through rooms because air carries tiny pressure changes from instruments to listeners. Without matter between the source and the listener, sound cannot travel normally. Space is different because most of it is astonishingly empty. Even though movies often portray space as crowded with roaring engines and explosive battles, the real cosmos contains vast stretches where there are only a few scattered atoms drifting through darkness. Between stars, there may be just a handful of particles in an area as large as a room. That emptiness is so extreme that sound waves have almost nothing to move through. If the sun suddenly vanished, Earth would continue orbiting the empty location for about 8 minutes before the last sunlight disappeared. During those final moments, there would still be no sound crossing space from the sun to Earth. Light and gravity travel across the void, but ordinary sound does not. This idea can feel unnatural because humans often connect large events with loud noise. On Earth, powerful things are usually noisy things. Avalanches roar down mountains. Oceans crash during storms. Rockets shake the ground with deafening force. Volcanoes erupt violently. Human brains expect energy to produce sound. But in space, energy often travels silently as light, radiation, or motion, rather than as audible noise. Astronauts experience this strange reality directly. Inside spacecraft, there are plenty of sounds. Machines hum constantly. Fans circulate air through cabins. Computers beep softly. Human voices echo through enclosed rooms. Spacecraft are never perfectly quiet because people and equipment create vibrations inside them. But outside the walls of the spacecraft, there is almost complete silence. When astronauts performed moonwalks during the 20th century, they moved through a world without atmosphere. The moon has no thick layer of air like Earth. Because of this, ordinary sound could not travel across its surface. If one astronaut struck a rock with a tool, another astronaut standing nearby would not hear it through open space. They could communicate only through radio systems inside their helmets. The moon itself is an incredibly silent place. No wind moves across its plains. No rain falls onto its dust. No forests rustle softly at night. Footprints left by astronauts may remain visible for millions of years because there's almost nothing there to disturb the surface. It is a world frozen in stillness. Yet silence in the universe does not mean absolute emptiness. There are still forms of hidden activity everywhere. Magnetic fields twist invisibly through space. Tiny particles stream outward from stars. Radiation crosses billions of kilometers silently. In some regions, clouds of gas slowly collapse to form new stars over millions of years. The universe is always changing, but often too slowly or too quietly for human senses to notice directly. Interestingly, scientists can sometimes convert cosmic activity into sounds humans can hear artificially. Certain waves from space can be translated into audio frequencies. Black holes, pulsars, and planetary magnetic fields can produce patterns that instruments transform into eerie noises. But these are not sounds traveling naturally through empty space to human ears. They are scientific translations of signals into something our minds can interpret. The silence of space also changes how humans emotionally imagine the cosmos. A noisy universe might feel chaotic or crowded, but the real universe often feels calm, distant, and patient. Even catastrophic cosmic events unfold across enormous timescales. A star may spend billions of years quietly burning before finally collapsing. Galaxies drift slowly through darkness for ages longer than human civilization has existed. This stillness can feel lonely, but it can also feel peaceful. Many people describe looking at the stars as calming because the universe appears detached from everyday stress and urgency. The stars do not hurry. Planets continue their slow paths regardless of human problems. The silence above Earth creates a sense of distance from ordinary life. There are places in the universe where matter becomes denser and sound could technically move through gas or plasma. Inside stars, vibrations ripple through incredibly hot material. Gas clouds near young stars may carry pressure waves. Scientists even study oscillations inside the sun itself. But these are not sounds that would travel openly across space into human ears. The immense emptiness between objects prevents most sound from moving far. The deeper humans study the cosmos, the more extraordinary the silence seems. The observable universe contains hundreds of billions of galaxies, each filled with billions of stars. Around many of those stars are planets. Some planets may contain oceans, storms, mountains, or even forms of life. Yet across these unimaginable distances, the universe remains almost entirely quiet. At night on Earth, this silence can sometimes be felt emotionally rather than physically. A person standing alone beneath the stars may suddenly become aware of the enormous darkness above them. The sky feels endless. Human life feels small and temporary beneath it. Yet, there is comfort in that feeling too. The quiet universe asks nothing from us. It simply exists, vast and patient, stretching outward beyond imagination. And while Earth continues spinning gently through space tonight, the silent cosmos surrounds it on every side. When people first begin learning about space, they often imagine the universe as crowded. Movies show starships weaving easily between planets and stars. Science fiction cities glow beneath neighboring suns. Galaxies appear packed tightly with light. But the true universe is defined less by objects themselves and more by the enormous emptiness between them. Space is not mainly made of stars or planets. It is mostly distance. The nearest star to Earth, beyond our own sun, is so far away that human minds naturally struggle to understand it. That star, known as Proxima Centauri, is about 4 light-years away. A light-year is the distance light travels in 1 year, moving at nearly 300,000 kilometers every second. Light is so fast that it can circle Earth more than 7 times in a single second. Yet even traveling at that incredible speed, light still takes over 4 years to reach the nearest neighboring star system. Human technology moves far more slowly. The fastest spacecraft ever created by humanity would still need thousands of years to travel that same distance. If every human life, from the construction of the pyramids until today, were combined into one continuous timeline, it still would not equal the travel time required for many ordinary journeys between stars. This is one reason the universe feels so quiet. Objects are separated by enormous oceans of emptiness. Even within galaxies, stars are rarely close together. From Earth, the night sky makes stars appear almost touching, like tiny lights scattered across a dark ceiling. But this is an illusion caused by distance and perspective. In reality, stars are separated by vast stretches of mostly empty space. If the sun were reduced to the size of a small orange, then Earth would orbit several meters away, tiny as a grain of sand. Neptune, the outer giant planet of our solar system, would circle far farther away still. And the next nearest star would not be in the same room, or even the same city. It would be thousands of kilometers away. This comparison helps reveal how astonishingly empty the universe truly is. Even inside our own solar system, the distances are difficult to imagine emotionally. Light from the moon takes only about 1 second to reach Earth. Sunlight takes around 8 minutes. But by the time signals reach the distant outer planets, hours may have passed. Spacecraft exploring the edges of the solar system communicate with Earth across billions of kilometers of darkness. The emptiness between worlds creates a strange kind of isolation. Every planet drifts alone around its star. Every solar system exists like a tiny island, in an enormous cosmic ocean. Between those islands lies darkness so vast that human language barely captures it properly. This enormous scale changes how events unfold in space. On Earth, things happen quickly because distances are relatively small. Weather moves across continents in days. Animals migrate across landscapes in weeks or months. Human travel between cities may take hours. But in the universe, even light requires years, centuries, or millions of years to cross certain regions. When astronomers observe distant galaxies, they are often seeing ancient light that began traveling long before human civilization existed. Some galaxies visible through powerful telescopes appear as they looked billions of years ago. Their light started crossing the universe before Earth even formed its modern oceans. In a sense, looking deeper into space also means looking backward through time. The emptiness of the cosmos also protects life on Earth in certain ways. If stars were packed closely together, gravitational disturbances could destabilize planetary orbits. Nearby stellar explosions might constantly threaten developing life. Instead, our solar system drifts through a relatively calm region of the galaxy with large distances separating neighboring stars. Silence grows naturally from these enormous separations. Even if intelligent civilizations exist elsewhere in the universe, they may simply be too far apart to easily contact one another. Signals weaken across immense distances. Civilizations may rise and disappear long before their messages arrive elsewhere. The universe may contain life scattered across countless worlds, yet still feel silent because the cosmic distances between them are almost unimaginable. There is also something deeply peaceful about this emptiness. The universe is not crowded or claustrophobic. It is spacious, beyond comprehension. Between stars lies darkness untouched for millions of years. Vast clouds of cold gas drift slowly through interstellar space. Lonely planets wander without suns. Ancient comets sleep in frozen silence, far from warmth and light. Astronauts who viewed Earth from space often described a powerful feeling of fragility. Against the enormous blackness of the cosmos, Earth appears small, bright, and delicate. The thin atmosphere surrounding the planet looks almost unbelievably fragile compared to the endless void beyond it. The emptiness of space makes our world feel precious. Even our galaxy, the Milky Way, contains immense regions where almost nothing exists. Though it holds hundreds of billions of stars, the galaxy is still mostly empty space. If humans could somehow travel safely between stars, much of the journey would involve drifting through darkness for years without passing near anything at all. Yet this emptiness is not completely lifeless. Tiny particles float through the void. Radiation crosses silently between worlds. Invisible gravitational forces shape the motions of galaxies. Occasionally, a lonely comet slowly tumbles through darkness for millions of years before briefly approaching a star and glowing once more. The quiet distances between stars create a universe that feels calm and patient. Everything moves slowly on cosmic scales. Stars orbit galactic centers over hundreds of millions of years. Galaxies drift through the universe with gradual motion, almost impossible for humans to notice directly. Even collisions between galaxies unfold so slowly that individual stars rarely strike one another. Tonight, somewhere above Earth, light from distant stars is crossing these enormous empty regions in silence. Some of that light began its journey before human history began. Some started traveling before dinosaurs walked across Earth. And after crossing unimaginable distances through the cold, quiet darkness, a tiny fraction of it finally reaches human eyes beneath the night sky. Among all the objects visible in the night sky, the moon feels closest and most familiar. For thousands of years, humans have watched it rise above forests, oceans, deserts, and sleeping cities. Its pale light has guided travelers through darkness, illuminated quiet roads at night, and reflected softly across calm water. Unlike the distant stars, the moon appears large enough for human eyes to notice details on its surface. People can see its changing shape, its shadows, and its slow movement through the sky. Yet despite how familiar it feels, the moon is one of the quietest places humans have ever encountered. From Earth, the moon often appears peaceful and comforting. It brightens the darkness without overwhelming it, and its light is softer than sunlight, cooler and calmer. Even today, many people feel relaxed simply by looking at the moon during a quiet evening. It seems gentle compared to the harsh brightness of daytime, but the moon is also an ancient world shaped by unimaginable loneliness and silence. Unlike Earth, it has almost no atmosphere. There is no breathable air, no weather, no wind moving across its plains, no rivers carve valleys through its surface, no forests grow beneath its skies. For billions of years, the moon has rested beside Earth in near complete stillness. The surface of the moon is covered with fine dust, created by countless impacts over immense periods of time. Tiny meteors and larger asteroids have struck the moon for billions of years because there is no thick atmosphere to protect it. On Earth, many incoming objects burn up before reaching the ground. Weather and erosion also gradually erase impact scars over time. But on the moon, craters remain visible for millions or even billions of years. This gives the moon a strangely frozen appearance. It looks ancient because it truly is ancient. Some footprints left there by astronauts during the 20th century may survive for an incredibly long time because almost nothing disturbs the surface. There is no rain to wash them away, no wind to scatter dust across them. The moon preserves moments in silence. During the Apollo missions, astronauts experienced a kind of quietness unlike anything on Earth. Inside their spacesuits, they could hear their own breathing, the sound of air systems operating, and radio voices from fellow astronauts or mission control. But outside those suits, there was almost nothing. If two astronauts stood apart on the lunar surface without radios, they would not hear one another speaking through the empty vacuum. The lunar landscape itself feels dreamlike because of this silence. Imagine standing on gray dust beneath a perfectly black sky. Even during daytime, the sun shines brightly, but there is no blue atmosphere to soften the light. Shadows appear extremely dark and sharp. The horizon curves gently nearby because the moon is much smaller than Earth. Above everything hangs the silent emptiness of space. And then there is Earth itself, glowing above the lunar horizon. Astronauts often described Earth, viewed from the moon, as emotionally overwhelming. Against the blackness of space, Earth appears bright, colorful, and alive. White clouds swirl above blue oceans and brown continents. Compared to the lifeless stillness of the moon, Earth looks almost fragile. The moon also changes the rhythm of life on Earth in subtle ways. Its gravity pulls gently on Earth's oceans, creating tides that rise and fall every day. For countless generations, humans living near coastlines watched the sea move according to the moon's slow cycles. Ancient cultures connected the moon to time itself because its phases changed predictably across the month. Even animals respond to moonlight. Some creatures become more active during bright full moons, while others hide more carefully from predators. Before artificial lighting existed, moonlight strongly affected nighttime life for both humans and animals. A bright moon transformed the darkness into something calmer and less frightening. There are places on Earth where the moon still feels almost as powerful as it did thousands of years ago. In deserts, remote mountains, or quiet oceans far from cities, moonlight can still dominate the landscape. The world becomes silver and soft beneath it. Familiar objects lose their daytime appearance and become quieter, gentler versions of themselves. Scientists believe the moon formed very early in Earth's history, after a massive collision between the young Earth and another large object. Debris from that collision eventually gathered together to form the moon we know today. In a way, the moon is connected to Earth not only by gravity, but also by shared origins stretching back billions of years. Without the moon, Earth might feel very different. The moon helps stabilize Earth's tilt as the planet rotates through space. This stability likely contributed to relatively calm long-term climate patterns that allowed life to develop over immense timescales. The quiet companion hanging above Earth may have helped create conditions that made human existence possible. Yet, despite its importance, the moon remains a profoundly lonely world. Day and night on the moon last far longer than on Earth. A single lunar day stretches across nearly an entire month. During lunar daytime, the surface becomes extremely hot under direct sunlight. During the long lunar night, temperatures plunge into deep cold. There are no sounds of weather between these extremes, only silence. Many people throughout history imagined the moon as mysterious or magical because it feels emotionally different from Earth. Sunlight energizes the world, but moonlight calms it. The moon belongs naturally to quiet hours, dreams, and reflection. It has washed over sleeping humans for all of recorded history. Tonight, while Earth continues turning beneath its atmosphere of wind, clouds, oceans, and endless human activity, the moon remains nearby in silent orbit. Its dusty plains rest untouched beneath black skies. Ancient craters lie frozen in stillness, and across the empty space between Earth and the moon, there is no sound at all. Only quiet light traveling gently through darkness. For most of human history, people wondered whether planets existed around other stars. The night sky was filled with countless distant lights, but no one knew if those stars had worlds of their own. Ancient civilizations imagined many possibilities. Some believed Earth stood alone at the center of creation. Others quietly suspected that the universe might contain endless hidden lands beyond human reach. But for thousands of years, nobody could truly know. Today, humanity has discovered that planets are everywhere. Modern telescopes have revealed thousands of worlds orbiting distant stars across the galaxy. Some are enormous gas giants larger than Jupiter. Others are small rocky planets similar to Earth. Some circle red stars glowing faintly in darkness, while others orbit suns far brighter than our own. There are worlds covered in ice, worlds heated by constant volcanic activity, and planets where storms may rage endlessly beneath thick clouds. The universe suddenly became much larger emotionally once humans realized how many worlds exist beyond the solar system. The stars no longer appeared as distant points of light alone. Each one became a possible system of silent planets drifting through the dark. Most of these planets will never be visited by humans. Many are so far away that even their faint light reaches Earth only after years or centuries of travel through space. Yet scientists can still study them carefully by observing tiny changes in starlight. Sometimes a distant planet passes in front of its star, causing a slight dimming visible to sensitive instruments. From these small clues, humanity slowly maps the hidden architecture of other solar systems. Some of these worlds are unimaginably strange. There are planets where molten rock may rain from the sky. There are giant worlds with crushing atmospheres and violent winds moving faster than sound. Some planets orbit so close to their stars that a single year lasts only a few Earth days. Others drift far from warmth and light in deep frozen darkness. And somewhere among these countless silent worlds, there may be places strangely peaceful. Astronomers have identified planets located within what is called the habitable zone, regions where temperatures might allow liquid water to exist. Water is important because every known form of life on Earth depends upon it. A planet with oceans, clouds, and stable temperatures becomes especially interesting to scientists searching for possible life beyond Earth. But even if life exists elsewhere, the universe still feels silent. No clear signals have arrived from distant civilizations. No spacecraft from another world has appeared in Earth's skies. The galaxy remains quiet, despite its enormous number of planets. This silence becomes more mysterious when considering how old the universe is. Many stars are billions of years older than the Sun. Some planetary systems formed long before Earth even existed. If intelligent civilizations arose elsewhere, they may have had immense stretches of time to grow, explore, or communicate. Yet from humanity's perspective, the cosmos still appears calm and empty. There are many possible explanations. Intelligent life may be extremely rare. Civilizations may disappear before spreading far into space. Vast cosmic distances may isolate living worlds from one another so completely that contact becomes nearly impossible. Or perhaps advanced civilizations simply remain quiet, hidden within the immense darkness between stars. The planets themselves continue orbiting regardless of whether anyone lives upon them. Across the galaxy, there are likely countless worlds experiencing silent nights beneath unfamiliar skies. Some may have frozen mountains beneath dim red suns. Others may possess enormous oceans stretching farther than any sea on Earth. There may be planets where snow falls under strange constellations no human has ever seen. Most worlds probably remain lifeless. Silent deserts of ice and stone drifting endlessly through space. Yet even lifeless planets can appear beautiful from afar. Some reflect pale blue light. Others glow softly beneath thick atmospheres. Giant ring systems may surround certain worlds like delicate floating circles, suspended in darkness. There are also rogue planets wandering alone through the galaxy without any star at all. These lonely worlds drift through deep space and permanent darkness after being thrown away from their original solar systems long ago. Imagine a frozen planet moving silently between the stars for billions of years, illuminated only by faint distant starlight. Such places may be among the quietest locations in the universe. The discovery of exoplanets also changed humanity's understanding of Earth. Our planet no longer seems like the only possible home for oceans, clouds, or perhaps life itself. Earth became one world among many, precious and beautiful, yet part of a much larger cosmic landscape. Still, there is something uniquely comforting about our own world. Earth is filled with sound and motion. Wind moves through forests. Rain strikes rooftops softly at night. Waves break along coastlines. Human voices echo through homes and cities. Compared to the silent planets drifting through the galaxy, Earth feels alive in a rare and vivid way. Astronomers continue searching the heavens for signs of life. Giant telescopes study distant atmospheres, looking for traces of oxygen, water vapor, or unusual chemistry. Scientists listen carefully for artificial radio signals hidden among cosmic noise. Spacecraft explore our own solar system, searching for possible microbial life beneath frozen moons or deep underground oceans. Yet so far, the universe answers mostly with silence. Perhaps this quietness is not emptiness, but distance. The galaxy is vast beyond ordinary understanding. Even light itself moves slowly compared to cosmic scales. Messages crossing the stars may require thousands of years to arrive. Entire civilizations could rise and vanish before their signals ever reach another world. Tonight, somewhere far beyond human sight, countless planets continue their slow journeys around distant suns. Some may be frozen in darkness. Some may glow beneath alien skies. Some may hold oceans reflecting unfamiliar moons. And across the immense silent distances between them, the universe drifts onward quietly, patiently, beneath endless fields of stars. When humans look up at the night sky, everything appears still. The stars seem fixed in place, calm and unmoving above the earth. Night after night, the constellations return in familiar patterns. To human eyes, the universe feels stable and motionless. But this peaceful appearance hides an extraordinary truth. Almost everything in the cosmos is moving constantly, only so slowly, and across such enormous distances that human beings rarely notice it. Earth itself is already moving in several ways at once. The planet spins around its axis at incredible speed, creating day and night. At the same time, Earth travels around the Sun at roughly 100,000 kilometers per hour. The Sun itself moves through the Milky Way galaxy, carrying the entire solar system along with it. And beyond even that, the Milky Way drifts through space among countless other galaxies. Yet, despite all this motion, the universe still feels quiet because cosmic movement happens across immense timescales. Human lives are short compared to the slow rhythms of the cosmos. Mountains can appear permanent to humans, even though they gradually rise and erode over millions of years. In the same way, galaxies seem motionless because their changes unfold over periods far longer than human civilization has existed. The Milky Way galaxy is enormous beyond ordinary imagination. It contains hundreds of billions of stars spread across a structure so large that light itself needs around 100,000 years to cross from one side to the other. From Earth, the Milky Way appears as a pale glowing band stretching across dark skies. Ancient people often imagined it as a river of light or heavenly mist because its true nature was impossible to see clearly with human eyes alone. Inside this vast structure, stars orbit slowly around the galactic center. Our sun takes roughly 230 million years to complete a single orbit around the Milky Way. When dinosaurs walked across Earth, the solar system occupied a completely different region of the galaxy. Since the time the dinosaurs disappeared, the sun has traveled only partway through one galactic year. This immense slowness gives the universe a dreamlike calmness. Galaxies do not rush. Stars drift gradually through their cosmic paths over millions or billions of years. Even dramatic galactic events often unfold so slowly that they would appear almost frozen from a human perspective. Some galaxies are spiral-shaped like the Milky Way, with long curved arms stretching outward through space. Others are giant elliptical collections of stars with softer shapes. Some are small, irregular galaxies that appear chaotic and uneven. Across the observable universe, there may be hundreds of billions or even trillions of galaxies, each containing countless silent worlds and stars. And these galaxies themselves are also moving. The Milky Way and the nearby Andromeda galaxy are slowly drifting toward one another. They are separated by an enormous distance. Gravity steadily pulls them closer together. One day, billions of years in the future, the two galaxies will begin merging. Yet even this colossal event will happen gradually across immense spans of time. The word collision makes humans imagine violent impacts and sudden destruction. But galactic collisions are strangely gentle because stars are so far apart. When galaxies pass through each other, most individual stars never actually collide directly. Instead, the galaxies slowly reshape one another through gravity, their structures stretching and changing over millions of years. If humans could somehow watch such an event in fast motion, the galaxies would resemble glowing clouds swirling together silently in darkness. Stars would shift into new orbits. Giant streams of light would arc outward across space. New waves of star formation might ignite as gas clouds compress. But throughout all of it, there would still be no sound in the vacuum of space. Galaxies also contain enormous regions of darkness between stars. Even dense galactic areas are mostly empty space. This emptiness contributes to the quiet feeling of the universe. Despite the unimaginable number of stars that exist, the cosmos remains spacious and calm. At the center of many galaxies lies a supermassive black hole. These objects contain masses millions or billions of times greater than the sun. The black hole at the center of the Milky Way quietly influences the motions of nearby stars through gravity. Yet even these mysterious giants often remain hidden in darkness, invisible except through their effects on surrounding matter. From Earth, the slow movement of galaxies becomes visible only through careful scientific observation. Telescopes reveal subtle shifts in starlight and galactic structure over time. Modern astronomy allows humans to understand that the universe is dynamic and changing even though it appears still to ordinary eyes. This hidden motion creates a strange emotional contrast. The cosmos feels peaceful because its changes happen so slowly, but beneath that calmness lies constant movement. Every star in the night sky is traveling. Every galaxy drifts through space. Even the universe itself continues expanding, carrying galaxies farther apart across unimaginable distances. And yet, despite this endless motion, the universe remains deeply quiet. There is something comforting about these slow cosmic rhythms. Human life often feels fast and crowded with urgency. Days pass quickly. Cities remain active constantly. Modern life moves with endless noise and pressure. But galaxies do not hurry. Stars burn steadily for billions of years. The universe unfolds with immense patience. Tonight, while Earth turns quietly beneath its atmosphere, the Milky Way continues its slow rotation through darkness, far beyond human sight. Other galaxies drift silently across the expanding universe. Ancient starlight crosses unimaginable distances toward Earth, and all around us, the cosmos moves with such calm slowness that it almost feels asleep. For thousands of years, humans have wondered whether someone else exists beneath distant skies. The stars appear so numerous that it feels difficult to believe Earth could be the only world with life. Every point of light in the night sky may represent another sun surrounded by planets, moons, clouds, storms, and perhaps living creatures looking upward just as humans do. Yet, despite this possibility, the universe remains strangely quiet. This mystery has become one of the most fascinating questions in modern thought. If the universe is so large, and if planets are so common, then why has humanity never clearly heard from another civilization? Why do the stars remain silent? The question itself feels surprisingly recent. For most of human history, people did not even know other planets existed around distant stars. But once astronomers discovered that worlds are scattered throughout the galaxy, the silence of the cosmos became more mysterious than ever before. The Milky Way alone contains hundreds of billions of stars. Many of those stars are older than the Sun. Around many of them orbit planets that may have existed for billions of years longer than Earth. Even if life is uncommon, the sheer number of worlds suggests that intelligent civilizations should perhaps exist somewhere among them. And yet, the night sky gives no obvious answer. This puzzle is often called the Great Silence. Humanity has listened carefully for decades, using large radio telescopes aimed toward the stars. Scientists search for signals that appear artificial rather than natural, patterns that might reveal technology created by intelligent beings. So far, no confirmed message from another civilization has ever been detected. There are many possible reasons for this silence. One possibility is that intelligent life is extremely rare. Perhaps simple life forms such as microbes exist on many worlds, but complex civilizations capable of building technology may emerge only under very unusual conditions. Earth's history involved countless unlikely events. Life survived asteroid impacts, climate changes, volcanic disasters, and mass extinctions across billions of years. Maybe worlds like Earth are far less common than humans hope. Another possibility is that intelligent civilizations do not last very long. Technological societies may eventually destroy themselves through war, environmental collapse, or uncontrolled technology before they spread far into space. In this scenario, civilizations appear briefly like tiny sparks in the darkness, then vanish before contacting one another. The scale of the universe itself may also create silence naturally. Distances between stars are so enormous that communication becomes painfully slow. Even a simple radio message sent from one side of the galaxy to another could require tens of thousands of years to arrive. A civilization might send signals long before another civilization even evolves enough to receive them. There is also the possibility that alien civilizations exist, but remain quiet intentionally. Perhaps advanced societies avoid broadcasting their location into space. The universe may contain hidden observers choosing silence over communication. Human beings themselves have only been sending detectable radio signals into space for a little more than 100 years, a tiny moment compared to cosmic history. Some scientists compare humanity to isolated island tribes before global exploration connected distant parts of Earth. Entire human cultures once lived unaware of one another. Simply because oceans separated them, the universe may operate similarly on a vastly larger scale, with civilizations scattered like distant islands across a cosmic sea too large to cross easily. The silence becomes even stranger when humans consider how old the galaxy is. If one advanced civilization had developed millions of years before humanity, it might have had enough time to spread widely across the stars. Yet there is no clear evidence of enormous galactic empires, giant alien structures, or obvious engineering projects visible from Earth. This absence of evidence creates a feeling both lonely and peaceful. Some people find comfort in the quiet universe. If the galaxy were crowded with powerful civilizations, the cosmos might feel less calm and mysterious. Instead, Earth drifts through what appears to be a vast, silent darkness. Human beings remain surrounded mainly by stars, planets, dust clouds, and empty space. Others feel sadness when thinking about this silence. The idea that humanity could be alone in such a large universe can feel emotionally heavy. Billions of galaxies stretch outward in every direction, yet perhaps no one else is there to witness them consciously. Still, many scientists remain hopeful. The search for life beyond Earth continues in many forms. Astronomers study distant planetary atmospheres for signs of biology. Robotic spacecraft explore moons within our own solar system, where hidden oceans may exist beneath thick ice. Radio telescopes continue scanning the heavens quietly, night after night. There are places in our solar system that seem especially intriguing. Beneath the icy surfaces of moons like Europa and Enceladus may lie deep oceans warmed by internal heat. In those dark waters, simple forms of life might survive far from sunlight. Even Mars may once have possessed rivers, lakes, and conditions more favorable to life long ago. Yet, even if life exists elsewhere, intelligent communication may remain incredibly difficult. Civilizations separated by thousands of light years cannot speak casually. Every message becomes an act of patience extending across centuries or millennia. The silence of the universe also changes how humans think about Earth itself. So far, this small planet remains the only known world filled with forests, oceans, music, cities, languages, dreams, and living creatures aware of the stars above them. Against the enormous quietness of space, Earth feels extraordinarily alive. At night, the stars continue shining with calm indifference. Somewhere out there, other civilizations may exist beneath alien skies, perhaps wondering about the same silence humans notice on Earth. They may be listening carefully to the cosmos just as humanity does, waiting for an answer that never seems to arrive. And across the vast darkness between worlds, the universe remains quiet, patient, and deeply mysterious. Among all the objects in the universe, few feel more mysterious than black holes. They cannot be seen directly in the ordinary way stars or planets can. They do not glow with steady light. They drift hidden within darkness, revealing themselves mainly through gravity and the strange effects they create around them. To many people, black holes sound violent and terrifying, cosmic monsters consuming everything nearby. Yet in reality, most black holes spend long periods in complete silence. The idea of a black hole begins with gravity, the same invisible force that keeps human feet on Earth and holds planets in orbit around the sun. Gravity pulls objects toward one another. The more mass something contains, the stronger its gravitational pull becomes. Stars possess enormous mass, which is why planets orbit them across space. A black hole forms when gravity becomes so strong that not even light can escape. Many black holes are born from the deaths of massive stars. A large star spends millions of years producing energy deep within its core. That energy pushes outward while gravity pulls inward. For most of the star's life, these forces remain balanced. But eventually, the star runs out of fuel. Without enough outward pressure to resist gravity, the core collapses inward with incredible force. Sometimes this collapse triggers a supernova explosion, one of the brightest events in the universe. For a brief moment, the dying star may outshine entire galaxies. But after the explosion fades, what remains can become something far stranger: a black hole. Once formed, the black hole itself becomes invisible. Its gravity is so intense that beyond a certain boundary, called the event horizon, nothing can escape outward. Not light, not matter, not signals. Everything crossing that boundary disappears from the visible universe. Yet despite this dramatic description, black holes are often quiet objects drifting silently through space. If our sun were magically replaced by a black hole of equal mass, Earth would continue orbiting almost normally. The gravitational pull at our distance would remain similar. The main difference would be the disappearance of sunlight and warmth. The planet would slowly freeze beneath dark skies, but Earth would not suddenly be pulled violently inward. This surprises many people because black holes are often imagined as cosmic vacuum cleaners sucking in everything nearby. In reality, they behave more like extremely dense invisible stars. Objects must come very close before the strongest effects appear. Some black holes exist quietly for millions or billions of years with little nearby matter to consume. Alone in the darkness, they drift silently through galaxies. Others sit hidden among stars where only careful observations reveal their presence. Scientists often detect black holes indirectly. When gas or dust falls toward a black hole, the material may form a rapidly spinning disk around it. Friction and gravity heat this matter to extraordinary temperatures, causing it to glow brightly before disappearing beyond the event horizon. In some cases, enormous jets of energy shoot outward from regions near black holes at nearly the speed of light. Even these dramatic events unfold in silence across the vacuum of space. At the center of the Milky Way lies a supermassive black hole called Sagittarius, a star. It contains millions of times more mass than the Sun. Yet despite its immense size, it remains relatively calm most of the time. Stars orbit invisibly around it, deep within the galactic center, guided by gravity through the darkness. Nearly every large galaxy scientists observe appears to contain a supermassive black hole at its center. Some are quiet, others actively consume enormous amounts of gas and dust, creating brilliant regions visible across vast cosmic distances. Ancient light from these energetic galactic centers still travels toward Earth after crossing millions or billions of years of empty space. Black holes also change the emotional atmosphere of the universe. The cosmos already feels quiet and immense, but black holes deepen that feeling. They are regions where normal human understanding begins to struggle. Time itself behaves differently near them. Gravity becomes so powerful that ordinary intuition no longer works properly. If someone could safely observe near a black hole, strange effects would occur. Time would appear to slow down compared to distant observers. Light from surrounding stars would bend around the black hole because gravity warps space itself. The universe near such an object would seem distorted and unreal. Yet black holes are not endless destroyers swallowing the entire universe. Most matter in galaxies remains far away from them. Stars continue their long, quiet lives. Planets orbit peacefully. Vast regions of space remain untouched by extreme gravity. There is also a strange stillness in the idea of the event horizon. Beyond that invisible boundary, information vanishes from the outside universe. Human imagination naturally wonders what exists there, but current science cannot fully answer the question. Black holes become symbols of the unknown, silent regions where certainty disappears. In recent years, humanity achieved something remarkable by creating the first image of a black hole's shadow. Using telescopes across Earth working together, scientists captured an image showing glowing material surrounding a dark central region. Even though the picture appeared blurry and distant, it represented one of the most extraordinary observations in modern astronomy. And still, despite all their mystery and power, black holes remain deeply quiet. No roaring sound emerges from the darkness around them. No cosmic scream echoes across galaxies. Matter may spiral inward with tremendous energy, but the vacuum of space carries no ordinary sound to distant listeners. The universe continues its silent motion while black holes drift hidden among the stars. Tonight, somewhere beyond human sight, countless black holes move quietly through the cosmos. Some wander alone between stars. Some sleep silently at the centers of galaxies. Ancient light bends around invisible gravity wells deep in the darkness. And across the enormous quiet universe, these mysterious objects remain among the calmest and strangest creations nature has ever formed. When most people imagine space, they picture emptiness. Endless blackness stretches between stars and planets, interrupted only by distant points of light. And while the universe is indeed mostly empty, it is not perfectly clean or completely vacant. Floating through the darkness are enormous amounts of tiny particles, cosmic dust, drifting silently across space for millions or even billions of years. This dust is everywhere. Some of it comes from dying stars. When large stars reach the end of their lives, they release material outward into space. Explosions scatter elements formed deep within stellar cores across surrounding regions of the galaxy. Tiny grains of carbon, silicates, metals, and ice spread outward slowly into the darkness. Over immense stretches of time, this material becomes part of giant drifting clouds between the stars. Even though the particles themselves are microscopic, these clouds can become unimaginably large. Some nebulae, the enormous clouds of gas and dust visible through telescopes, stretch across distances larger than entire solar systems. Within these silent regions, new stars may eventually form. Cosmic dust sounds insignificant because dust on Earth often feels ordinary or unwanted. It gathers quietly on shelves, windows, and forgotten objects. But in the universe, dust plays an important role in shaping planets, stars, and perhaps even life itself. Long ago, before Earth existed, the material that would eventually become our planet drifted through space as tiny particles surrounding the young sun. Dust slowly collided and stuck together. Small grains became larger clumps. Larger clumps became rocks. Over millions of years, gravity gathered enough material to form planets, moons, and asteroids. In a sense, Earth itself began as drifting dust. Human bodies also contain atoms created inside ancient stars. Elements such as carbon, oxygen, calcium, and iron formed through stellar processes long before the solar system existed. The iron in human blood and the calcium in human bones were once part of stars that died billions of years ago. The universe quietly recycled its material across unimaginable spans of time. Much of cosmic dust moves so slowly and silently that it almost feels frozen. Tiny grains drift through darkness, illuminated faintly by distant starlight. Some particles may wander the galaxy for millions of years before becoming part of another star system or planet. Others remain suspended inside cold interstellar clouds where temperatures drop to astonishing levels. There are regions of space where dust becomes so dense that it blocks visible light almost completely. Giant dark nebulae appear like shadows against richer star fields behind them. Ancient observers, looking into the Milky Way, sometimes noticed strange dark gaps among the stars. Without realizing, they were seeing enormous clouds of cosmic dust. Inside these clouds, gravity works patiently. Over very long periods, regions of gas and dust slowly collapse inward. Temperatures rise, pressure increases. Eventually, new stars ignite deep within the darkness. Entire solar systems may emerge from these quiet stellar nurseries. This cycle gives the universe a gentle rhythm. Stars form, shine, die, and return material back into space. Dust drifts through galaxies until gravity gathers it again and into new worlds. Cosmos continuously reshapes itself over billions of years with incredible patience. Some cosmic dust eventually reaches Earth. Every day, tiny particles from space fall gently through Earth's atmosphere. Most are so small that humans never notice them. Some burn up high above the planet as faint meteors. Others settle invisibly onto oceans, forests, rooftops, and deserts. Tiny traces of ancient stars quietly land on Earth constantly. There is something calming about this idea. The universe is not completely separate from human life. Earth remains connected to the cosmos through invisible exchanges happening all the time. Ancient particles born in distant stars eventually become part of planets, oceans, and living things. Astronauts who visited the moon encountered a different kind of dust. Lunar dust covering the silent surface in fine gray layers. Because there is no wind or water on the moon, the dust remains sharp and dry rather than rounded by erosion. The astronauts described it as strange and clingy, sticking stubbornly to spacesuits and equipment. Elsewhere in the solar system, giant rings surrounding planets like Saturn are also made partly from countless tiny particles. Ice and dust orbit together in delicate structures, glowing softly beneath sunlight. From a distance, these rings appear smooth and peaceful, but up close they contain endless fragments drifting quietly through space. Cosmic dust also changes the appearance of the night sky itself. Dust clouds scattered throughout the Milky Way absorb and scatter starlight, creating dark lanes stretching across the galaxy. Some regions glow softly because nearby stars illuminate surrounding dust with faint colored light. Through telescopes, these areas resemble enormous paintings suspended in darkness. The silence of drifting cosmic dust deepens the peaceful feeling of the universe. Nothing rushes. Tiny particles float gradually across impossible distances. Entire clouds evolve over millions of years. The cosmos does not move with human urgency. It unfolds slowly, almost like breathing. Even comets contain ancient dust preserved from the earliest days of the solar system. When comets approach the sun, heat releases gas and dust into glowing tails stretching across space. For brief moments, these wandering objects become visible from Earth. Silent travelers carrying material unchanged for billions of years. Tonight, beyond the atmosphere above Earth, tiny particles continue drifting through darkness between the stars. Ancient dust from long-dead suns moves quietly across the galaxy. Invisible grains pass through cold nebulae, where future worlds may someday form. And somewhere far beyond human sight, the universe patiently continues its endless cycle of creation and stillness, one silent particle at a time. Humanity has always imagined travel as something full of movement, change, and discovery. On Earth, even long journeys are measured in hours, days, or months. Ships cross oceans, airplanes cross continents, and roads connect distant cities. But once the idea of leaving the solar system is considered, travel stops feeling familiar. It becomes something entirely different. Something closer to stillness stretched across unimaginable time. The space between stars is so vast that even light, the fastest thing in the universe, moves slowly across it from a human perspective. A beam of light leaving one star may take years, decades, or even centuries to reach another. And yet, for all this motion, there is no sound, no wind, no sensation of movement in the ordinary sense. Interstellar travel is not just long, it is profoundly quiet. If a spacecraft were able to travel beyond the edge of our solar system, the first thing it would encounter is emptiness. The sun would shrink into a distant point of light, slowly fading into the background of other stars. Planets would become invisible. The warmth of the sun would weaken until it no longer reached the ship in any meaningful way. From that point onward, the spacecraft would be surrounded almost entirely by darkness and silence. Inside the spacecraft, life would continue normally. Machines would hum. Air systems would circulate oxygen. Humans would speak to one another. But outside the hull, there would be nothing to hear. No wind, no vibration traveling through space. No distant echoes of other worlds. The universe would feel like an enormous empty ocean where sound simply cannot exist. As the spacecraft travels farther, even familiar stars begin to change. The constellations that once guided ancient travelers on Earth would slowly distort. Patterns that once felt permanent would shift as the ship moves through different regions of the galaxy. Eventually, the sun itself would no longer be distinguishable from the surrounding stars. At that point, the spacecraft would no longer feel like it is traveling through a familiar neighborhood. It would be moving through true interstellar space, a region so empty and vast that distances become difficult to measure in everyday terms. The nearest star might be many years away at the speed of light. Entire lifetimes would pass before reaching even a single neighboring solar system. This is one of the quietest experiences imaginable. Even communication becomes a challenge. A message sent from a spacecraft to Earth would take years to arrive. A reply would take years more. Conversations would stretch across generations. By the time an answer returned, the original sender might no longer be alive, and the civilization that sent the message might have changed completely. In such conditions, interstellar travel feels less like movement and more like isolation stretched across space. The spacecraft becomes a small island of life drifting through an enormous silent ocean. There is no nearby destination, no immediate horizon, only distant points of light that may or may not ever be reached. And yet, even within this loneliness, there is a strange kind of calm. The silence of deep space removes distraction. There is no weather, no day or night cycle, no familiar sounds of Earth. Time becomes the main companion. Days pass slowly. Years pass quietly. Outside the ship, stars drift almost imperceptibly across the viewports, their motion so gradual it feels almost frozen. If humans ever travel between stars in the future, they may experience this silence for very long periods. Entire generations could live and die aboard the same vessel, never stepping onto another world. The ship itself would become a small, self-contained environment moving through a universe that remains largely unchanged around it. Some regions of interstellar space are even more empty than others. Vast bubbles of near-nothingness exist between dense clusters of stars. Inside these regions, matter becomes extremely sparse. A spacecraft traveling through them would encounter almost nothing for millions of kilometers at a time. Only distant starlight would provide any sense of direction. There is also a strange emotional aspect to this kind of travel. Humans are used to environments filled with signals. Voices, footsteps, music, weather, and natural sounds all create a sense of presence. In deep space, much of that disappears. Even silence on Earth still contains subtle background noise. But interstellar space approaches a kind of absolute quiet. This quietness can feel both peaceful and unsettling. Peaceful because there is no chaos, no danger rushing from every direction, no immediate threat or pressure. The universe simply exists, steady and vast, but also unsettling, because the silence feels so complete that it emphasizes how far everything is from everything else. Even light from distant galaxies arrives slowly, carrying information from ancient times. A traveler deep in space would see the universe not as a busy place, but as a slow, unfolding memory. Distant stars would shine like reminders of regions that may never be visited. And yet, despite this loneliness, the universe is not empty in meaning. Every direction still contains structure, history, and motion on enormous scales. Galaxies continue to rotate. Stars continue to form and die. Planets continue to orbit unseen suns. Life may exist somewhere within that vast silence, even if it remains unreachable. Interstellar travel, whether real or imagined, reveals something important about the universe. It is not designed for speed or convenience. It is built on patience, distance, and time that stretches far beyond human experience. Tonight, as Earth continues its quiet rotation beneath the sky, the space beyond our solar system remains still and dark. Between the stars lies an almost perfect silence, broken only by faint light traveling across unimaginable distances. And somewhere in that silence, the idea of travel itself becomes less about movement and more about enduring the calm emptiness between worlds. Stars feel permanent when viewed from Earth. They appear every clear night, fixed in their positions, unchanged year after year. Yet every star in the universe has a life cycle. They are born, they shine, and eventually they fade away. The universe is not only full of light, but also full of quiet endings that unfold slowly over millions or billions of years. A star begins its life inside a vast cloud of gas and dust. Gravity slowly pulls this material together. As the cloud collapses, it heats up, and at its center a new star is born. For most of its existence, a star remains stable, quietly balancing the inward pull of gravity with the outward pressure created by nuclear reactions in its core. This long, stable phase is where most stars spend the majority of their lives. During this time, stars burn steadily, producing light and heat in a calm, continuous rhythm. The sun is in this stage right now. It has been shining for billions of years and will continue to do so for billions more. From a cosmic perspective, this is a quiet existence. Nothing dramatic happens for long stretches of time. A star simply burns, radiates energy, and holds itself together. But eventually, even this stability begins to change. As stars age, they slowly run out of the fuel that keeps them shining. When this happens, their structure begins to shift. Some stars expand into enormous red giants, growing so large that they could engulf entire planetary systems. Others shed their outer layers gently into space, forming glowing clouds of gas that drift outward in beautiful shapes. These clouds are called planetary nebulae, even though they have nothing to do with planets. The name comes from early astronomers who observed their round, planet-like appearance through small telescopes. In reality, they are the quiet remains of dying stars, slowly dispersing their outer layers into the universe. In these final stages, stars do not usually die in sudden noise or chaos. Instead, they fade in gradual transformation. The outer layers drift away. The core changes state. Light becomes softer, dimmer, and more distant. The universe does not rush these endings. It allows them to unfold across long periods of cosmic time. Some stars end their lives in more dramatic ways. Massive stars may collapse and trigger supernova explosions, releasing enormous amounts of energy. For a short time, a single exploding star can shine brighter than an entire galaxy. Yet even these events, despite their intensity, remain silent in space. The light spreads outward, but no sound travels with it through the vacuum. After a supernova, what remains depends on the mass of the original star. Some remnants become neutron stars, incredibly dense objects where matter is compressed to extreme levels. Others become black holes, regions where gravity becomes so strong that nothing can escape. But even these remnants are part of a larger calm cycle. Over long periods of time, The debris from dying stars spreads through space. Elements created inside stars, such as carbon, oxygen, and iron, are released into interstellar clouds. These materials eventually become part of new stars, new planets, and new systems. The universe continuously recycles itself in a slow and quiet rhythm. This means that everything in the universe is connected through time. The atoms inside planets, oceans, and living beings were once inside stars that lived and died long before Earth existed. Dying stars do not simply disappear. They become part of everything that follows. From a distance, star death might seem chaotic, but on cosmic timescales, it is incredibly orderly. Stars follow predictable life cycles depending on their size and composition. The universe does not act randomly. It moves through patterns that repeat across billions of years. Even the brightness of stars changes in subtle, rhythmic ways. Some stars pulse gently, expanding and contracting over time. Others slowly shift color as they age, moving from hot blue tones to cooler red hues. These changes happen so gradually that they are only visible when observed over long periods. If a human could watch a star evolve in fast motion, it would resemble a slow-breathing light. Expansion, contraction, dimming, brightening, then eventually fading into darkness or transforming into something new. Yet from Earth, these processes are almost invisible. Human lifetimes are too short to witness the full life of a star. A star that appears unchanged in the sky tonight may already be in a different stage of its evolution compared to millions of years ago. There is something calming about this slow cosmic rhythm. The universe does not erase stars abruptly. It allows them to fade gently, like distant lights slowly dimming in the vast darkness of space. Even the most powerful explosions in the cosmos are softened by distance and time. As stars die, they also create space for new beginnings. The material they release becomes the foundation for future worlds. Dust clouds enriched with heavy elements slowly gather again under gravity. New stars ignite. New planetary systems form. The cycle continues without interruption. This constant transformation gives the universe a quiet sense of renewal. Nothing truly ends in isolation. Everything becomes part of something else over time. And throughout all of this, space itself remains silent. There are no echoes of dying stars traveling through the vacuum. No sound of collapse or explosion moving between galaxies. Only light carries information outward, crossing vast distances long after the original event has passed. Tonight, in distant regions of the Milky Way, some stars are quietly reaching the ends of their lives. Their outer layers drift gently into space. Their cores change state in ways too slow and too distant for human eyes to witness directly. And across the universe, the rhythm of stellar life and death continues in a calm, silent cycle that has been repeating for billions of years. Out in the far reaches of space, beyond the warmth of familiar stars, there are worlds that exist in near complete darkness. These are planets that receive little to no sunlight, where temperatures drop to extremes far below anything experienced on Earth. They are not burning, not glowing, not alive with weather or wind in any familiar sense. Instead, they drift in cold silence, locked in what feels like eternal night. Some of these frozen worlds orbit far away from their stars, in regions where sunlight is so weak that it barely warms the surface. Others may have once been warm and active, but slowly drifted into colder regions over time. There are also planets that do not orbit any star at all, wandering alone through space without a sun, carried only by the slow motion of gravity across the galaxy. On such worlds, time feels different. Without sunlight rising and setting, there is no natural cycle of day and night. There are no seasons in the way humans understand them. If any form of atmosphere exists, it may be thin, still, and unmoving. If oceans exist, they may be frozen solid beneath thick layers of ice. These planets are shaped by cold and stillness rather than heat and movement, even though they seem lifeless. Frozen worlds are not necessarily empty in a chemical sense. Many still contain water, gases, and complex materials. Some may have subsurface oceans hidden beneath layers of ice, warmed slightly by internal heat from radioactive elements or gravitational forces. In these hidden regions, conditions might be more stable than on the surface above, but from the outside, everything appears silent and still. Light from distant stars reaches these worlds as faint illumination, sometimes barely enough to cast shadows. In regions far from any star, even starlight is weak. The surface of a frozen planet may remain in darkness for millions or billions of years, illuminated only by distant galaxies or passing cosmic events. There is a strange stillness in imagining such places. On Earth, even the quietest environments contain motion. Snow falls, rivers flow beneath ice, wind shifts sand across deserts. But on a frozen world far from any star, there may be no wind, no flowing water, no visible change for incredibly long periods of time. These planets are shaped more by absence than by presence. The absence of heat, the absence of light, the absence of atmospheric activity. Yet even in this absence, gravity continues to work. Ice slowly shifts over geological timescales. Craters accumulate from rare impacts. Internal heat may create subtle movement deep below the surface. Some of these worlds might drift through interstellar space as rogue planets. Once ejected from their original solar systems, they travel alone between stars. There is no sunrise, no sunset, only the faint glow of distant starlight that slowly changes as they move through the galaxy. A rogue planet could travel for billions of years without encountering a star again. During that time, it would remain almost completely unchanged on the surface. Any motion would be extremely slow, almost imperceptible. From a human perspective, it would feel like a frozen moment stretched across eternity. Yet even these lonely worlds are part of the larger cosmic cycle. They may eventually pass near a star again, or they may collide with other objects drifting through space, or they may simply continue their silent journey indefinitely in the outer regions of some star systems. Similar frozen worlds exist in great numbers. Beyond the main planetary orbits, there are belts of icy bodies and distant objects that orbit their stars in extremely wide paths. These regions are cold, dark, and quiet, filled with remnants from the formation of solar systems. Some of these distant objects occasionally shift their orbits, traveling inward toward the warmth of their stars. As they approach, they begin to change. Ice begins to vaporize. Dust and gas are released, forming glowing tails that stretch across space. For a brief period, these once frozen objects become visible as comets, silent travelers crossing the inner regions of solar systems. But most of the time, they remain far away in darkness, preserved in cold silence. Frozen worlds also help reveal how diverse the universe truly is. Not every planet is warm, active, or familiar. Many exist in conditions far beyond human experience. Some are locked in perpetual night. Others may have atmospheres so thick and cold that light barely penetrates them. Some may have surfaces made of exotic ices that behave differently under extreme conditions. Despite this variety, these worlds share a common trait. They are quiet. There are no sounds traveling across their surfaces. No weather systems producing audible storms in the vacuum of space. Even if something dramatic occurs, such as an impact or internal shift, the sound cannot travel outward into space itself. The silence of frozen worlds is not emptiness, but isolation. Each planet exists alone, separated by enormous distances from any possible neighbor. Even if two such worlds drift near each other in cosmic terms, the space between them remains vast compared to anything experienced on Earth. This isolation gives frozen worlds a dreamlike quality. They feel paused, as if time itself has slowed down around them. Yet they are not truly stopped. They continue moving through space, orbiting unseen stars or wandering between them, following the invisible structure of gravity. In the far future of the universe, frozen worlds may become even more common. As stars age and fade, fewer sources of heat and light will remain. More planets will drift into darkness. The universe may gradually become a colder place, filled with quiet, frozen objects moving slowly through expanding space. Still, even in that distant future, motion will continue. Gravity will still guide planets, stars, and galaxies. Light from ancient sources will still travel outward for billions of years, and the universe will remain active in ways that are almost entirely silent. Tonight, somewhere far beyond human sight, frozen worlds continue their slow journeys through darkness. Some orbit distant stars in wide, quiet paths. Others drift alone through interstellar space, carrying their cold silence across the galaxy. And above them all, the universe stretches outward in calm stillness, filled with worlds that shine only faintly, or not at all, beneath the endless night. Far beyond the familiar planets of Earth, Mars, and Jupiter, the solar system does not end abruptly. It slowly fades outward into colder, darker, and quieter regions where sunlight becomes weaker and more distant. There is no clear wall marking the boundary of the solar system. Instead, there is a gradual transition from worlds of light and activity into vast regions of near silence. The outer solar system feels almost like a forgotten place. The sun, which dominates life on Earth with warmth and brightness, becomes only a distant star in the sky when viewed from these outer regions. Its light is still present, but it is faint, taking hours to reach distant objects instead of minutes. Beyond the gas giants lies a region filled with icy worlds and scattered debris. These objects are remnants from the formation of the solar system, preserved in cold darkness for billions of years. Many of them are small, rocky, or icy bodies that never formed into planets. They drift quietly in slow orbits, far from the energy of the inner solar system. As distance increases, motion becomes slower and quieter. The sun's gravity still holds everything together, but its influence weakens gradually. Objects in these distant regions take extremely long times to complete a single orbit. Some may take hundreds or even thousands of years to circle the sun once. Even farther out lies a vast spherical region filled with icy bodies and ancient debris. This region extends so far that it approaches the boundary between the solar system and interstellar space. It is a place where the sun's influence is still present, but extremely faint. Objects here move in slow, gentle paths shaped by weak gravitational forces and occasional disturbances from passing stars. This outermost region is almost entirely invisible from Earth without powerful instruments. Yet it is filled with countless silent objects, each one traveling through space in isolation. Some of these objects occasionally shift inward toward the sun, becoming comets that briefly light up the inner solar system before disappearing again into darkness. The edge of the solar system is not a sharp border, but a soft fading into interstellar space. At some point, the sun's influence becomes so weak that passing stars and galactic forces begin to play a larger role in shaping motion. This transition marks the beginning of true interstellar space, where distances between stars dominate everything. Even though this region is vast, it is extremely quiet. There is no atmosphere, no sound, no wind, and no weather in the familiar sense. Objects drift through darkness with almost no interaction. Collisions are rare. Changes happen slowly over immense periods of time. One of the most distant structures associated with the solar system is a vast cloud of icy bodies surrounding it like a faint shell. This region stretches far beyond the orbits of known planets, and even beyond most distant comets. It is so large and so spread out that objects within it are separated by enormous distances, making it almost empty in practical terms. From this distant region, the sun would appear extremely faint, just another star among many others. The concept of daylight loses meaning entirely. Everything is dominated by darkness and distant starlight. Spacecraft that travel outward from Earth experience this transition gradually. First, they leave Earth's atmosphere, then pass the moon, then travel beyond the inner planets. As they continue outward, the sun becomes smaller and dimmer. The warmth it provides fades until only a faint glow remains. At extreme distances, communication between Earth and spacecraft becomes slow and delayed. Messages take hours or even days to travel one way. Human presence becomes less immediate, replaced by signals crossing vast emptiness. This quiet edge of the solar system is also a reminder of how fragile and small the region of life truly is. Earth exists in a relatively warm and active zone close to the sun. Here, energy is abundant, temperatures allow liquid water, and dynamic weather systems shape the surface. But this comfortable region is only a tiny part of the entire solar system. Beyond it lies coldness, stillness, distance, and yet, even in this outer darkness, there is structure. Gravity continues to organize motion. Objects follow paths shaped by ancient formation processes. The solar system remains a coherent system, even at its edges, held together by the invisible influence of the sun. As the boundary between solar and interstellar space is crossed, the environment changes again. The influence of the sun becomes secondary. Other stars begin to matter more. The spacecraft or object is no longer simply leaving a system. It is entering a wider galaxy filled with countless other systems, each with its own quiet boundaries and distant edges. But the feeling remains similar. It is still silence, still distance, still slow motion across vast emptiness. The outer solar system feels like a long, fading memory of light. Distant objects preserve the early history of planetary formation, frozen in time. They carry traces of how the solar system once looked, billions of years ago, before planets fully settled into their current orbits. Even now, these regions continue to evolve, slowly, quietly, without noise or sudden change. Just gravity, time, and the faint glow of a distant sun. And beyond them, the universe continues outward, even more silent and even more vast. One of the most quietly powerful ideas in the universe is that light does not arrive instantly. It travels. It moves continuously through space, crossing enormous distances, carrying information from places that may no longer exist in the same form. What we see in the night sky is not the universe as it is right now, but the universe as it was ago. This means that every clear night is also a kind of time window. When light leaves a star, it begins a journey across darkness. That journey might take minutes, hours, years, or even billions of years before it reaches another place. During that time, the source of the light continues changing. A star might age, shift in brightness, or even die completely. A galaxy might evolve, rotate, or merge with another galaxy. Yet the light already traveling outward continues on its path, unaffected by what happens after it was emitted. On Earth, sunlight takes about 8 minutes to reach us. That means when humans see the sun, they are always seeing it as it was 8 minutes ago. If something dramatic were to happen on the sun, it would not be visible immediately. There would always be a delay, a quiet gap between reality and perception. This delay becomes far more extreme when looking deeper into space. Light from the moon takes about 1 second to arrive. Light from nearby planets can take minutes or hours. But light from stars outside our solar system takes years. Some stars we see in the night sky are actually images of the past, light that began its journey before many human civilizations even existed. As distance increases, This effect becomes more profound. Light from some stars may have started traveling before written history began. Light from distant galaxies may have been on its journey since long before Earth had oceans in their current form. And light from the most distant visible regions of the universe has been traveling for billions of years, carrying information from the early stages of cosmic evolution. In a sense, looking into space is also looking backward in time. This creates a universe that feels layered. Nearby objects show the recent past. Farther objects show deeper history. The most distant light reveals ancient conditions of the cosmos, when galaxies were younger and more chaotic. Everything is connected through this slow, continuous movement of light across space. Even though light is incredibly fast, the universe is so large that it still feels slow. The vast distances between stars and galaxies transform even the fastest messenger in existence into something patient and delayed. Light becomes a traveler, carrying silent memories across cosmic oceans. Some of this ancient light still reaches Earth today. It arrives steadily, night after night, as faint starlight and distant galaxy glow. Each photon has crossed unimaginable distances, passing through regions of space that contain almost nothing at all. It has traveled through darkness so complete that there is no scattering, no sound, no interruption, only empty space and time. When telescopes observe distant galaxies, they are essentially collecting ancient light. They are capturing images of objects as they once were, not as they are now. A galaxy seen today may have already changed dramatically, or even ceased to exist in the same form. But its light continues traveling outward, preserving a frozen moment in cosmic history. This creates a strange kind of cosmic memory. Unlike human memory, which exists in minds, the universe stores memory in light itself. Every photon is a tiny record of a place and time. Together, they form a vast archive stretching across space, constantly being written and slowly delivered to new regions of the universe. Ancient light also reveals how dynamic the cosmos truly is. Stars are born, live, and die. Galaxies form structures and then slowly reshape them. Collisions occur between enormous systems over billions of years. Yet because everything happens on such long time scales, the universe appears calm when observed moment by moment. There is also something deeply quiet about this process. Light travels silently. It does not disturb the space it crosses. It does not create waves in the vacuum that humans can hear. It simply moves forward, carrying energy and information across emptiness. Even the most powerful cosmic events, such as supernova explosions or energetic galactic centers, become silent once their light leaves the source. The universe does not echo these events in sound. It only preserves them in radiation traveling outward. This means that much of what humans know about the universe is based on ancient signals arriving now from far away. The night sky is not just a view. It is a collection of time-delayed messages arriving continuously from different parts of the cosmos. Some of these messages are incredibly old. They have been traveling since early cosmic history, when the universe was still forming its large-scale structure. Others are relatively recent in cosmic terms, still on their way toward Earth from nearby stars. All of it arrives quietly. There is no sound accompanying this information, no warning or announcement, just faint light appearing in the sky after long journeys through darkness. Each point of light represents something distant, something separated by time and space, something that continues to exist far beyond human reach. And yet, despite this separation, ancient light connects everything. It links Earth to distant stars. It links the present to the deep past. It links human eyes to events that happened long before life existed on this planet. Tonight, as darkness settles over Earth, countless streams of ancient light continue their slow travel through space. Some are just arriving now after journeys that began billions of years ago. Others are still on their way, moving quietly across the universe, carrying the memory of distant worlds through the endless silence of space. The deeper humanity looks into the universe, the stranger its quietness becomes. At first, space seems silent simply because it is empty. There is no air to carry sound, no wind to move vibrations, no atmosphere to transmit noise from one place to another. But as observation improves and understanding grows, the silence begins to feel less like a simple physical fact and more like a question that stretches across the entire cosmos. The universe is not just quiet in one place. It is quiet everywhere we can observe. This is what makes the great silence so mysterious. When scientists first began searching for signals from other civilizations, they expected the universe to feel active in a communicative sense. With so many stars and so many planets, it seemed reasonable to assume that at least some worlds would develop technology capable of sending messages across space. Yet, as telescopes and instruments became more sensitive, the expected signals did not appear. Instead, the universe remained still. This absence is not the absence of activity. Galaxies rotate, stars explode, planets orbit, black holes consume matter. Energy flows through space in countless forms. But none of this activity arrives as clear signs of communication from distant intelligence. The cosmos continues its physical motion, but it does not speak in any way that humans can recognize. This creates a strange feeling of scale mismatch. The universe is active beyond imagination, yet it feels silent in terms of contact. It is as if something enormous is happening everywhere, but nothing is reaching across the distances in a way that connects different parts of the cosmos together in conversation. There are many possible explanations for this silence, and none of them are confirmed. One idea is that intelligent life may be extremely rare. Another is that civilizations may not last long enough to spread or communicate widely. Another possibility is that advanced civilizations exist, but do not use methods that are detectable from far away. Or perhaps the universe is simply too large, and signals weaken or become lost long before they can reach another world. But beyond these explanations, there is a deeper feeling that comes from the silence itself. It suggests separation. Even if life exists elsewhere, the distances between stars are so large that interaction becomes extremely difficult. Civilizations might exist in isolation without ever knowing about one another. Each star system could be like a closed island surrounded by an ocean of empty space, too wide to cross easily, too quiet for messages to travel reliably. On Earth, isolation is temporary. Oceans can be crossed, mountains can be passed. Communication between distant regions becomes possible through technology. But in the universe, isolation is built into the structure of space itself. Distance is not just a challenge. It is a fundamental condition. This is why the silence feels so persistent. Even when Earth sends signals into space, they spread outward as faint expanding waves. Over time, they become weaker, blending into background noise. Eventually, they become indistinguishable from natural cosmic radiation. The message continues traveling, but it becomes harder and harder to detect as it spreads across the galaxy. Meanwhile, Earth also listens. Radio telescopes scan the sky, collecting signals from distant regions. They search for patterns that might indicate artificial origin. So far, nothing definitive has been found. The sky remains filled with natural noise, but no clear signs of structured communication from other civilizations have been confirmed. This does not necessarily mean the universe is empty of life. It may simply mean that communication across such distances is far more difficult than expected. Another possibility is timing. Civilizations may rise and fall at different points in cosmic history. One civilization might exist millions of years before another even begins. In a universe billions of years old, two intelligent societies might never exist at the same time long enough to exchange messages. Signals may pass through empty regions of space without anyone there to receive them. There is also the idea that silence itself is part of natural cosmic development. As civilizations grow, they may become less detectable. They might shift toward communication methods that do not spread widely into space. They might focus inward rather than outward, or they might simply exist in ways that are not easily visible from a distance. Whatever the reason, the result is the same. The universe feels quiet. This silence is not absolute emptiness. It is a lack of clear connection across vast distances. Stars still shine. Planets still orbit. Galaxies still evolve. But communication between distant regions remains unconfirmed and uncertain. And so the universe continues to appear both full and silent at the same time, full of motion, energy, and structure. Silent in terms of shared voices across space. This dual nature creates a kind of cosmic stillness that is difficult to describe. It is not the silence of nothingness. It is the silence of separation, where everything exists, but almost nothing is directly connected in ways humans can perceive. Tonight, across the galaxy, countless stars continue shining without interruption. Planets continue their silent orbits. Radiation travels across space, but between distant worlds, there is only vast distance. And within that distance, a quiet that stretches across unimaginable scales. Deep within the galaxy, there are places where space is not completely empty. Instead, it is filled with enormous, delicate clouds of gas and dust, drifting slowly through darkness. These regions are called nebulae, and they are among the most visually gentle and quietly beautiful structures in the universe. From a distance, a nebula may appear as a soft glow against the blackness of space. Through telescopes, they can look like faint smoke, colored in subtle shades of red, blue, green, or violet. But these colors are not loud or sharp. They are soft and diffused, as if the universe itself is slowly breathing light into the darkness. Nebulae are formed in different ways. Some are the remnants of dying stars, clouds of material pushed outward when a star reaches the end of its life. Others are regions where new stars are being born, slowly gathering matter under the influence of gravity. In both cases, nebulae represent transition, the universe changing form without noise or sudden movement. Inside these clouds, space is still extremely empty compared to Earth. But compared to the near-perfect vacuum of interstellar space, nebulae are dense enough for atoms and particles to interact over long periods of time. This allows slow processes to occur, such as the formation of new stars and planetary systems. Even so, everything happens in silence. There is no wind moving through these cosmic clouds, no thunder, no sound waves, no audible activity. If a human could somehow float inside a nebula, they would see glowing mists surrounding them in all directions, but hear nothing at all. The experience would feel like drifting through a silent dream made of light and dust. Some nebulae are incredibly large, stretching across hundreds of light years. That means light itself takes hundreds of years to travel from one side to the other. Within these enormous regions, countless small processes unfold at the same time. Gas slowly collapses here. Radiation from nearby stars illuminates distant edges there. Yet none of this movement creates sound in the traditional sense. Nebulae are also deeply connected to the life cycle of stars. When stars die, they release material into space. That material becomes part of these clouds. Over time, gravity gathers parts of the cloud together, forming new stars. Those new stars may later die and return their material to space again. This creates a continuous cycle of birth and transformation across the galaxy. It is a cycle that happens quietly over billions of years. Some nebulae are shaped by powerful radiation from nearby stars. Intense light can carve structures into the clouds, creating pillars, waves, and glowing edges. Even though these formations may look dramatic, they are formed through extremely slow interactions between light and matter over long periods of time. One famous example is a region where towering columns of gas and dust rise like giant shapes in space. Inside these structures, new stars are being formed, hidden within dense pockets of material. These stellar nurseries are among the most important places in the galaxy because they are where new suns begin their existence. Yet even in these active regions, everything remains quiet. The universe does not use sound to shape nebulae. It uses gravity, radiation, and time. These forces operate silently but persistently, shaping the structure of clouds across vast distances. Nebulae also help reveal how interconnected the universe truly is. The material inside them often comes from many different sources. Some of it originated in ancient stars that died long before the solar system existed. Some of it may have traveled across space for millions of years before becoming part of a cloud. Nothing in the universe is truly isolated. Everything is part of long cycles of movement and transformation. From Earth, nebulae appear faint because they are so far away. Without telescopes, most of them are invisible to the human eye. But when observed carefully, they reveal themselves as some of the most expansive and delicate structures in the night sky. They remind us that space is not only empty darkness, it also contains subtle beauty. Spread thinly across enormous distances, nebulae also contribute to the calm feeling of the universe. They do not rush. They do not explode suddenly. Even when shaped by powerful forces, they evolve slowly, almost imperceptibly on human timescales. A nebula seen today will look nearly the same thousands of years from now. This slowness creates a sense of cosmic patience. The universe does not demand attention. It changes quietly, without urgency. Even the most energetic processes are softened by distance and time. In the far future, nebulae will continue their role in the cosmic cycle. New stars will form within them. Old stars will return material to them. Galaxies will continue to reshape them gently through gravity. And through all of this, they will remain silent, glowing softly in the darkness of space. Tonight, in distant regions of the Milky Way, vast clouds of gas and dust continue drifting through space. Within them, new stars are slowly forming in hidden regions. Light from nearby suns illuminates their edges in soft colors. And across the enormous distances of the galaxy, nebulae remain as quiet, floating structures of change, turning the universe gently over time without a single sound. On Earth, time feels closely tied to human life. Days are measured by waking and sleeping. Years are marked by seasons, birthdays, and personal memories. Entire civilizations are built, rise, and change within what feels like long stretches of history from a human point of view. But when viewed against the scale of the universe, human existence is only a brief moment in a much larger flow of time. Before humans existed, Earth was already active for billions of years. Oceans formed and disappeared. Continents slowly shifted across the surface of the planet. Life began in simple forms and gradually evolved into more complex ecosystems. Dinosaurs lived, thrived, and vanished long before modern humans appeared. And long after humans eventually disappear, Earth will continue orbiting the sun in silence. The universe does not depend on human presence. Stars will continue to burn. Galaxies will continue to rotate. Black holes will continue to exist. Even if humanity vanished entirely, the cosmic rhythm would remain unchanged. From a cosmic perspective, humans are observers who arrived very late in the history of the universe. The stars had already been shining for billions of years before anyone on Earth looked up at them. Light had already been traveling across space long before human eyes existed to receive it. If humanity were to disappear in the future, the universe would not notice in any conscious way. There would be no change in the movement of galaxies or the life cycle of stars. The silence of space would remain exactly the same, because it was never shaped by human presence in the first place. Earth itself would slowly continue its natural processes. Cities would fade over time. without maintenance. Structures would erode under wind, water, and temperature changes. Forests would reclaim land. Oceans would continue rising and falling with tides influenced by the moon. Over extremely long periods, human traces would gradually disappear from the surface. But the planet would remain. Earth would still orbit the sun in a steady, quiet path. The sun would continue shining for billions of years, gradually changing as it ages. Eventually, it will expand into a red giant, altering the inner solar system in profound ways. Long before that happens, Earth's surface conditions will have changed many times. In the wider galaxy, stars would continue their slow motion. Nebulae would form and disperse. New stars would ignite from clouds of gas and dust. Old stars would fade or collapse into dense remnants. Planets would continue orbiting silent suns and distant systems. The universe after humans is not empty. It is full of ongoing processes, but it is also indifferent in the sense that it does not rely on awareness or observation to continue existing. One of the most striking ideas is that most of the universe already exists in a state that would feel unchanged without humans. Vast regions of space contain no life, no observers, no signals of intelligence. They operate entirely through physical laws, unaffected by whether they are seen or not. In this sense, human presence adds awareness to the universe, but not control over it. If future intelligent life continues beyond humanity, it may eventually observe deeper regions of the cosmos. It might study distant galaxies, explore interstellar space, and perhaps even travel between stars. But even then, the scale of the universe would remain overwhelming. There are regions so distant that their light has not yet reached Earth. There are galaxies moving away so quickly that their future light may never be seen. The observable universe itself is only a limited window into a far larger structure that extends beyond what can be directly measured. After humans, the universe would still expand. Space itself would continue stretching. Galaxies would slowly drift farther apart. In extremely distant future scenarios, the night sky could become darker as galaxies move beyond observable range. The cosmos would grow more isolated over time on the largest scales. Yet even in that future, stars would still shine locally. Planetary systems would still exist. Gravity would still shape motion. The fundamental structure of the universe would remain intact. There is a quiet continuity to all of this. The universe does not pause for observers. It does not accelerate or slow down based on attention. It simply continues. Human existence, then, becomes a brief phase within a much larger cosmic timeline. A moment when the universe became aware of itself in a small region on a small planet for a short period of time. And even that awareness is part of the universe's natural unfolding. Tonight, Earth continues its rotation beneath the sky. Cities glow softly on its surface. Oceans reflect faint starlight, and far above, the same universe that existed long before humans and will continue long after them stretches outward in quiet motion, unchanged in its silence, endlessly continuing its slow and patient existence. One of the most subtle and least intuitive features of the universe is that space itself is expanding. This is not like objects moving through space in the usual sense. Instead, the very distances between galaxies are slowly increasing over time. The fabric of space is stretching, and as it stretches, everything embedded within it becomes more separated. From a human perspective, this idea is difficult to visualize because it does not match everyday experience. On Earth, distances remain fixed unless something moves. A room does not expand on its own. Roads do not stretch apart. Buildings stay in place unless forces act upon them. But on the largest scales of the universe, space behaves differently. Galaxies are not simply flying apart like fragments from an explosion. Instead, space between them is growing. This means that even if galaxies are not moving through space in the traditional sense, the distances separating them increase as space itself expands. Inside galaxies, gravity is strong enough to hold structures together. Stars, planets, and solar systems remain bound within galaxies. But between galaxies, where gravity is much weaker, expansion becomes noticeable over extremely long periods of time. This process is incredibly slow from a human point of view, yet over billions of years it reshapes the entire structure of the cosmos. As space expands, distant galaxies appear to move away from us. The farther away a galaxy is, the faster it seems to recede. This does not mean they are all moving through space away from a central point. Instead, every region of the universe experiences the same expansion, causing distances everywhere to increase simultaneously. If you were standing on a distant galaxy, you would observe the same effect. Other galaxies would appear to be moving away in all directions. There is no single center of expansion. The universe expands everywhere at once. This expansion carries a quiet, almost imperceptible quality. There is no sound, no visible force pushing galaxies apart, no sudden change. It happens gradually, over timescales so large that even entire civilizations would not notice it directly, without careful observation. Light traveling through expanding space also changes. As it stretches, its wavelength becomes longer. This is why light from distant galaxies appears shifted toward red tones when observed from Earth. The light itself is unchanged in origin, but the space it travels through slowly stretches it over time. Even though this process is subtle, its consequences are profound. Over extremely long timescales, galaxies that are currently visible in the night sky may drift so far away that their light will no longer reach Earth. Future observers might see a much emptier sky, with fewer distant galaxies visible. Yet even in this expanding universe, local structures remain stable. Gravity holds galaxies together. Stars continue to orbit within them. Solar systems remain intact. On smaller scales, space does not expand in a way that tears objects apart. The effect only becomes significant across vast cosmic distances. There is something deeply quiet about this expansion. It does not involve collisions or explosions on a universal scale. It is a gentle stretching, like a slow unfolding of space itself. The universe is not rushing outward in a chaotic burst. It is expanding steadily, evenly, and silently. From a philosophical perspective, this gives the universe a sense of calm motion. Everything is moving apart, yet nothing is being violently pushed. It is a gradual separation measured in billions of years, unfolding without noise or disturbance. Even the idea of distance becomes relative in an expanding universe. The space between 2 points is not fixed forever. It can grow, meaning that journeys across cosmic scales become more complex over time. A destination that is visible today may become unreachable in the distant future, not because it moves away in space, but because the space between continues to grow. This expansion also affects how the universe will look far into the future. If one could observe the cosmos billions of years from now, many distant galaxies would no longer be visible. The observable universe would become more isolated, with only nearby galaxies remaining within view. The rest would fade beyond the cosmic horizon. Despite this, local cosmic activity would continue. Stars would still shine within galaxies. Planetary systems would still orbit quietly. Life, if it exists, would still experience time normally within gravitationally bound regions. The expansion of space does not interrupt local existence. It simply changes the large-scale structure of the universe. The universe, then, is both dynamic and quiet at the same time. Dynamic, because it is constantly expanding and evolving. Quiet, because these changes occur without noise, without resistance, and without any sense of urgency. It is a motion that cannot be heard, only understood through observation over vast timescales. Tonight, across the universe, Space continues its silent expansion. Galaxies drift slowly apart, carried not by force, but by the stretching of space itself. Light continues its long journey through growing distances, and the cosmos unfolds steadily, quietly, and endlessly, in a way that feels less like movement and more like a slow and peaceful unfolding of everything that exists. Every moment, the universe is filled with signals, not signals in the sense of messages meant for someone, but physical traces of activity traveling through space. Light from stars, bursts of radiation from distant galaxies, faint energy released by collisions of cosmic objects. All of it moves outward in all directions, crossing enormous distances without interruption. Yet almost all of these signals are never received in the way they might be intended, because there is no clear sender or receiver built into the structure of the cosmos. Instead, space acts like an immense archive of traveling information, where most messages fade, scatter, or become indistinguishable long before reaching anything that could interpret them. A signal in space does not stay strong forever. As it spreads outward, it becomes weaker. It covers larger and larger areas, thinning out as it expands. By the time it reaches extreme distances, it may be so faint that it blends into the background of the universe, indistinguishable from natural cosmic noise. This fading is not sudden. It is gradual, almost patient. A powerful event can send out energy that travels for billions of years, but as it expands, it stretches and disperses. What once was bright and distinct becomes faint and diffuse, until it is no longer recognizable as something specific. In this sense, the universe is full of forgotten signals. Some of these signals come from stars that no longer exist. A star may explode or collapse, but the light it emitted during its life continues traveling outward long after the star itself has changed. For distant observers, that light still carries the memory of a star that may have already disappeared. Other signals come from energetic cosmic events like supernovae or the activity around black holes. These events release enormous amounts of energy, briefly making them some of the brightest phenomena in the universe. But even these powerful signals are subject to the same fate. They spread outward, weaken over time, and eventually blend into the vast background of space. There is also a deeper layer to this idea when considering the possibility of communication between civilizations. If intelligent life exists elsewhere, any signals it produces would also face this same challenge. A message sent across space would begin clearly structured and intentional, but as it travels, it would expand outward, become diluted, and gradually lose clarity. Over great distances, even carefully designed signals might become indistinguishable from natural radiation. The universe does not preserve meaning in a direct way. It preserves energy, but not necessarily interpretation. This creates a kind of cosmic filtering process. Only signals that are strong enough, close enough, or carefully directed have a chance of being recognized. Everything else slowly fades into the background of the universe. Because of this, space can be thought of as a place where countless messages are continuously being sent, but very few are ever fully received in their original form. Even light itself, which carries so much information, eventually becomes stretched and weakened by distance. Ancient light from galaxies arrives at Earth, carrying a snapshot of the distant past. But even that light is only a small fraction of what originally left those sources. Between the origin and the destination, much of the original structure of the signal is lost, simply due to distance and time. This is not caused by interference in the traditional sense. Space is not full of obstacles that block signals in most regions. Instead, the fading happens because of expansion, distance, and the natural spreading of energy across the universe. In extremely distant future scenarios, this process becomes even more pronounced. As the universe continues to expand, more regions move beyond the observable horizon. Signals from those regions may never reach other parts of the cosmos at all. They continue traveling outward, but the space between grows faster than the signal can cross it. From that perspective, entire regions of the universe could become permanently isolated from one another. Signals sent today might never reach some parts of space, no matter how long they travel. This introduces a quiet form of separation that does not involve barriers or walls. It is simply the result of distance, increasing over time. Yet within this vast fading network of signals, there is still structure and continuity. Many signals do reach their destinations. Light from stars reaches planets. Radiation from cosmic events reaches detectors. Information about the universe still flows, even if much of it is lost along the way. The universe is not silent because nothing is happening. It is silent because most of what happens is too distant, too weak, or too dispersed to be fully recognized across space. There is also something poetic about the idea of forgotten signals. Every bright event in the universe begins with clarity and intensity, but over time, it becomes part of a larger background, a soft echo traveling through space long after its source has changed. In this way, the universe carries an invisible history, not as records stored in a single place, but as layers of fading light and energy overlapping across billions of years. Even now, Earth is surrounded by such signals. Light from distant stars, faint radiation from ancient cosmic events, and countless other traces of activity pass through the solar system continuously. Most of them go unnoticed, passing through without interaction. Only a tiny fraction of cosmic signals are ever captured or understood. The rest continue onward, fading gradually into the endless expansion of space. And so the universe remains filled with messages that travel forever, but are rarely fully heard.